what are we actually going to demo here? So we're going to demo here how to deploy your application straight from source code. And the how is like, if you look at this DevOps age, like the continuous cycle, then we have this deploy, operate, and monitor area, which is all kind of comes from when you have your software written as some kind of release artifact and you want to kind of deploy it. And there are platforms there, but if your code base suits a certain format, they will just be able to deploy it for you, which basically means they will do the heavy lifting for you of this undifferentiating like workload. So there's no need to reinvent how to deploy your website to a static web host or how to deploy a container, if that's something kind of nearly every organization will be doing. So in this demo, I will be looking at two main ways on how to do this. They mostly differ in how the deployment infrastructure looks, what we will be targeting. This will put some constraints on what kind of application you can deploy, and it also changes the properties of the resulting deployment. They're not mutually exclusive. You can have an application which fits both of these models, but you will see that especially the first option I will start talking about is way more constraining on the code base, but has some nice things you get from it for free as a result. So the first way is like CDN plus serverless functions. So a CDN is a content delivery network. Basically, they're good at sharing static files, and serverless functions are a way to run compute in the cloud on demand, which scales usually to 0. In this way, it's very easy to distribute files like globally around the world. So there's global CDNs, and it tends to be that it's completely pay-per-use. So hosting the files is relatively cheap. Having serverless functions which are not invoked is also nearly cost-free. But then only when they're invoked, you will incur cost, which means as a result, your application scales to complete 0 when there's no use, which you will see in development is actually quite neat, because now we can have a lot of environments or deployments running at the same time. And as long as we don't use them anymore, we actually don't even incur cost. This does require that your application in some shape or form builds into static resources and these serverless functions, which often means that it's easiest if you have a framework which supports it out of the box. There are relatively many frameworks which build static sites, but they're kind of constrained. There are fewer which are also doing these serverless functions, but one popular one nowadays is Next.js. It's a product by Vercel. It's completely open source, and Vercel is also very good at hosting this service. And besides that, we'll be looking at AWS Amplify and Netlify, who have a very similar service offering where they can deploy these static apps and set apps with serverless functions onto their infrastructure. The second category is a bit more traditional. There will be deploying long-lived applications, such as containers or VMs. Often it doesn't really matter for your source code, like whether it is a VM or a container. But the fact is that you will end up with this long-living process, which means that you always incur cost, even if it's not used, but it tends to fit more workloads. Some examples are Azure Web Apps, which uses VMs. Then Heroku is container-based. Flight.io and DigitalOcean app platform works slightly different. Flight.io uses Firecracker VMs, from whom is not aware or doesn't know this term. It's what AWS Lambda uses. So they pioneered this technology. It supports deploying like it's a container. So we can kind of pretend that we're deploying containers, even though it's not really, at least not the Docker containers we're mostly used to. So to just crash into the demo time area. All the instructions will be in this repository. I will send in the chat also the link, so you can click there and you don't need to type it over or scan the QR code. In this repository, you will find the README files, such that you can tag along if you want. So step by step, you can go through it. You can also just watch now and do it later at your own pace, as you so desire. We'll be deploying to multiple platforms, so you don't need to do all of them. You can also just pick one or two and just see how I deploy to the other ones. And part of them have a completely free tier. Part of them, one will have and it will end in the end. will require you at least have a credit card. You won't be billed because it will stay within their free tier, but they want to avoid malicious use. They want to make sure that there's at least some kind of background check. And then the one provider, AWS, is not as easy to get an account. But you'll see that it's all very similar, and you can do it later on your own pace if you do not have this set up. Good, let's get into it. So when you open up the repository, you will see this first README greeting you. The first application we will be deploying is a modern web app. So the first category, it will deploy to a CDN with function as a service. It's a Hacker News clone. Hacker News is a link aggregator, let's call it like that. So kind of Reddit, but then a bit of a niche. And they have a public API, and I chose this because it's very nice. You don't have to get an API key for yourself, so you can just tag along and don't have to kind of fiddle with these details. So it's relatively easy to deploy. This is a custom UI for this news aggregate. So we'll be seeing that same content, just different UI. And now we're going to deploy it on our own infrastructure. We will be deploying this to Vercel, Netlify, and AWS Amplify, 3 different providers which have very similar processes. I think Amplify has a bit of is a bit more heavy, but as a result, you can customize more, while Vercel and Netlify are more focused or laser focused, I guess, is on this kind of one use case. Yeah, like I said earlier, you can pick one or multiple to kind of tag along. The thing with AWS Amplify is you need to have an account, which can be a bit more tedious to set up. Well, Vercel and Netlify should be quite easy to just follow along, either connect with your GitHub account or just create a new account there. So first steps first, there is a repository prepared, the adorno/next.js-hacker news. If you go there, in the top right, you can fork it. We'll fork it because we will enable directly deploying it from the Git repository. All these providers come with nice integrations, which do this connecting your deployed application infrastructure to your Git repository, such that if you push a change, it will automatically pick up. And we get things like when you create a new branch or you create a new pull request, you get these feature environments. You can do this manually through, they all come with CLI, such that you can push your deployment changes to the cloud, and then they will deploy it for you there. So in case, let's say you want your CI to automatically deploy on every push, then you can use the CLI tool instead of this out-of-the-box integration. But especially if you're just evaluating these platforms, and these kind of integrations, if they work for you because you're using a supported Git provider, then it's an easy way to just get started and get a feel of what it actually can deliver. And then later on, you can build these more complex CI solutions to actually actively push the versions you want. Good. So let's get into this. Let's first put Vercel. Yes, put a team just to isolate things. You don't need to have the pro license for this. You can just stay on the free tier. Free for every tier is actually quite generous. So if you go to create new projects, then you can connect it to Git. So if you directly connect it to GitHub, here you will see the option to deploy it. Click on import, and we'll give us some options. So it already figured out that we're running a Next.js project. It uses it analyzes the project structure to kind of pick up on that. See that Vercel has quite a lot of options out of the box. You can where it knows it, but you can also customize it a bit. They have a very standardized build process. So it will run, it will install dependencies when your builds come on, and then you will need to tell it where it can find the artifacts you're willing to deploy. They're mostly Node.js focused, but you can build Python and at least Go-based applications with them too. For example, my personal website is Yugo-based. Very neat thing is that they deploy my website within 2 seconds. It's blazing fast, but that's a complete static site builder. So in this case, Next.js will also offer this possibility to showcase these serverless functions deployments there. Let's go with deploying. Cool. So yes, while this is running, this will probably take 30 seconds to a minute. We can also do the same for Netlify. Again, oh, I'm still logged in. Yes, let's go. Again, creating a new project by connecting it to our GitHub account. Except in default branch, again, you get this like build configuration. Because it sees it's an Next.js site, it will pre-configure most of the things correctly for us. In this case, for example, it's custom .next directory, which is the usual output. You can tweak it if needed. So let's go. Deploy these two in time. Cool. So this is finished. 1 minute later, the first one ready. One, amplify. So after having done two, amplify. Creating a new app, can connect to GitHub. You see, Amplify also has a support in their UI from the deployment without Git provider. With the other ones, you would need to kind of build it yourself with the CLI tool. Select the repository. It will prompt you to set up this integration if you're following along. Select the branch, main branch. We're not on a monorepo. Let's see. So here we have a bit more, well, we see the very similar set of options we would have also in Vercel, but from experience, I can tell you these build settings, you can actually get quite advanced. For example, information into the builder, or we can even give it a complete custom builder image. So then AWS will image source code in the builder image, and like so you can have full control over which tool is available when you're building, which makes it quite flexible. Deploy. There we go. There. This one's done too. Yes. Okay. Let's one more thing. Already give it a nicer name. So two. This tends to be that amplifies a bit slower. They're a bit more heavy. Well, because they give you so much customizability on how this building works, they're less good at actually caching the build artifacts in between. So it's a bit of a trade-off. Vercel and Amplify can really optimize the entire build process because they have a kind of constrained way to actually building your application. While in Amplify, because you have more freedom, they don't have this very deep caching support. So you'll see slower builds, but it's still kind of should be 3 minutes, 5 at the end of the roll. So what do we have now? We have a static web app. If you actually look under the hood, the network console. See what's happening. So we have a lot of static files, which is kind of typical for Next.js, which are all mostly served in a bit of a waterfall fashion. When the browser fetches the first index of HTML, it knows what to figure out and download from that later. So that's why we see this waterfall happening. There's a lot of code splitting happening out of the box with Next, and there will be some HTTPS calls towards the dynamic data source, where in this case, we're using Firebase for actually obtaining the data of this website. So by itself, it's completely static, and all the kind of dynamic data we're seeing is coming from this API. And then if we go to /API/hello, one small serverless function, the application doesn't use it much, just here showcasing that it does deploy this. So this is just a REST API, JSON RPC API running on serverless functions. In this case, it just prints back to client and a hello message. But your app could kind of call into this. So if you want, you can have some kind of server-side logic here as well, which complements your static web app. Let's see. I can at least turn in more. I need to do that most. Let me know if it's that won't help for that first. Okay, I will make this one smaller and reshare then only this window. Yes, I will be staying within browser. It should be fine. Let me reconnect this. One window. This one. Better. I hope so. Good. So yeah, that's the kind of the serverless function side. And you can use this to build like host complete APIs. Although one model which works quite well is that kind of a three-tiered web app with like static front end, one light API, which is just there to kind of help the front end fetch dynamic data without needing to be aware of your upstream API, and then some kind of like other data source. And the advantage here is that your UI or that your API doesn't need to, or you have one API in the middle, which is kind of responsible for being aware of what the UI needs, so that you're not kind of having this UI-driven design in your kind of data or your original source API. Or if you don't have control over this original API, then there you can layer in things like authorization, so that it doesn't leak into the actual front end where the browser would get access to this information. So let's see if, yes, hello, Amplify. So also with Amplify, we just got this new application. Let me put the links in chat so that you can open it yourself, see what we've got. 3 times the same application. Okay. Now that I've renamed it. Go. And the third one. So yeah, all very similar stuff. Connected to Git. So we'll see later that we can actually, if we push now new changes, we'll automatically get the new deployments here too. Let's go back to my notes. Or skip over things. Some names. Yes, cool. So yeah, evaluation. I already showed the API endpoint for a second. Yeah, developer experience. So let's say like we want to make a change, like how does developer work with this and what do they get with these platforms? So I think that's for me one of the main things. What I like a lot about this is that it's not just deploying your production environment, but you get this kind of lightweight environments when you're developing, which you can share with your teammates, and makes it easier to review and get confidence in that if you merge that PR into your main branch, what you will deploy is actually stable and actually working, without having to do, well, one, local build and testing it, or spinning it up to kind of a testing environment. Both is overhead, and even then, like often not even guaranteed that they are on the same infrastructure. So as just a dummy thing, here's /site header. Hello. Just gonna do a bit of a hello world editing. Just gonna change this title into hello t.news. Branch. We'll actually see if we refresh. Chris already picked up that we have a new commit. They're very eager to kind of deploy everything they get their hands on. Pull request, and we'll see that Netlify by default starts building soon too. In Amplify, it will not default to actually building all of your branches. Previews, one off. If you enable this, what it will do is it will register a deploy key into your GitHub repo, so that it has read access on it. Will not do it now. Yeah, I mean I could. So good at that. Yes. Should already have access. Yes. Hasn't picked up on the branch yet. I think the preview feature of Amplify is a bit more. You have more control, but it's a bit more work to kind of set it all up and get it to work, to play nice. In the meantime, on the PR, yeah, we see at least that with Fritzl and Netlify picked up on the PR, started to deploy it. So just finished. You see there's a full preview environment ready with our TDOG news now here. Netlify is still, no, it also finished. Good. So that's the same. So this is a very easy way to kind of share links, and you can immediately share this with your teammates, and they can just access it normally. The deployments are tied to the commit. One chance to see if we can start picking up on the new branches. If not, then I will leave it out. There. Yep. Okay. So it's enabled. It should work now. Just before it works pretty well. I'm sure if it actually now that I would need to push again for it to pick up. It's a very similar experience. Well, we will get these like temporary environments for all our pull requests. Well, so now that we've seen that our changes works, what we can do is we just scratch and merge it in. You'll see that on our main branch, we start deploying it to our production environment. And it gets picked up. So that's kind of the flow you get with these environments. It's a very way to kind of share and have like confidence in the change you're making that actually works, and to see to see also what others are working on, and get that, like, even if you don't have it checked out locally, you can still kind of just jump to their version. Okay, cool. We're ready. So, fresh. We'll see that current now jumped from this one to this one, and even the old version will actually still be around. So that might feel a bit odd, because kind of on the commit, we have still the release running. So we still have this old production release. So if you want to do like a kind of a git bisect, but then manually, you can kind of figure out when, let's say, a bug is introduced, which is kind of going through historical commits. So these are permanently, or they're not entirely permanent. There's a limit on how much Vercel will retain for you. Depends a bit on your pay tier, but they survive quite long, and at least in my experience, I've had quite a lot. That I sent the link to a preview environment to our product manager, and I, like, later on he tries to show it to our customers, and in the meantime the PR is merged, and we clean up everything, and boom, they hit like a 400 or 404 because we already cleaned up that environment. And this way, those links will also keep working. They actually show what was at that point the feature to be demoed. Okay, so now that we've seen from the developer side, I also want to take a bit on how does the end user actually experience the deployment we get, and to make a bit more of a realistic situation, I'll be using Bunny. It's a CDN provider which has a tool to make HTTP requests from all around the globe to a certain endpoint, so that we get a bit of visibility into how long does it actually take to obtain one of these pages from any place on the globe effectively. You'll see quite a lot of variance in most cases, based on where you're actually accessing the site from. It's very easy to kind of verify that, I don't know, if you have if you deploy your application to a data center around the block, that everything goes very smooth, but then kind of real end users from a different continent will probably have a different experience from your web app. So let's start with just taking for ourselves, like hitting the root of the web page. See, the first load is actually quite slow everywhere. Quite often you'll see that if you run this multiple times, we'll run it in a sec again, that the latency difference will go down a lot. This has to do with both DNS lookups, which cost time and which will be cached, and also just caching of the actual files, HTTP request on the edge servers, so on the CDN. So we see that first load, it was around 400 to 600 milliseconds nearly everywhere. Well, now even in Australia, we're looking at 60 milliseconds. So what happened is that after the first request was made, all the caches were filled, such that if I reload it again, we still have this kind of low, or we get these cache hits. Vercel is also responsible for doing cache invalidation. So if you push a new version, then they will invalidate the caches on the edges, which means that the first request again can be slow, but then afterwards, like if you have multiple users hitting your site, then these next subsequent requests will get a cache hit and be relatively fast. Let's see. So yeah, that's just a root. Let's take same from that reply. Seems slightly better propagated. Kind of interesting to see that here we have kind of low times while it seems to spread out. So looks like all of these requests somehow were blocked by North America. This is a bit of a weird outlier. But you see that in the farther we get away from America, like you get higher times. Not a reload. You see that the caches have propagated mostly based in fiery regions. So it's physically impossible that all these requests were served from one region, because the latency between these 2 points is way more than these 2 milliseconds. So we see that in the edges, they're not performing that well. Not sure why, actually. Expect them to be slightly better. But let's see, second request. Bit better luck. Yeah, okay, just need to hit up. And lastly, amplify. What's the bug? But this one region doesn't respond. Like it's kind of blocking everywhere. And also Russia is not really served well these days. So again, you get this quite a cache miss. But then on subsequent requests, we get a cache nearly everywhere. So quite a quick time to first paint on these requests for end users nearly everywhere. As long as you're nearby one of these, in this case, this will be deployed to AWS CloudFront. So yeah, if you live near one of those CDN endpoints, then it doesn't really matter where you live. You'll get on a cache hit, very quick service. If we do the same for the /hello, we'll see the server type rendered logic. That is harder to cache. So see different characteristics here. Reload normally does have a bit of warm-up time, but often in this case it looks like the requests are still served from the US, and then they kind of at some point need to route back. So you can see that here the serverless functions is actually deployed to like all their edge locations, but seems to be only there in the US. It's not per se bad, just that in this case, actually the reason why it's in the US is probably because I deployed it to in the US region. This demo earlier, and then I was in Europe. I just don't remember where it was then. But anyway, you want your data to be close to, if your serverless function is making requests against your data source, you will want your data source and your serverless function to be close together, because often it needs to do a couple of back and forths. And that if that has a high latency, then that all will compound. So in that way, it's better that your serverless function lives closer to your data source than that it lives closer to the user. The request will go once to the serverless function, and then maybe a couple of times back and forth to your database or another API. And every back and forth adds one entire round trip. So you can actually see that with edge computing, if you do need to make a call back home, it can make your end user experience a lot worse even. The cell on the free tier also defaults to deploying everything to one region. The pay tier, you get a lot more. They can configure which regions they're serving from. But with serverless functions, because the resources aren't always provisioned, so what you'll see is that it's not just caching, but it's that these functions, they need to start up. There's no compute waiting for them to kind of be standby. So you need to kind of probe them to kind of get them to start doing things. So it's again seems like Eastern US. So times are quite bad to the north of it.
By the way, there is also a question in question and answers section.
How does per commit environments get cleaned up to not accumulate cost for stuff that is no longer needed? It depends on the provider. for one, the Vercel Netlify's payment or cost structure doesn't include storage for itself. Like you get a fixed amount of things for Vercel's like 100 gigabytes on even their cheapest tiers, which is kind of hard to exceed. And then the costs are quite marginal in general for having these static assets on the CDN. So it doesn't quickly actually seem to become a problem. I think for Vercel in the free tier, you get like 100 deployments from the top of my head, and then it's paid to their sales to kind of get more. Amplify is a bit more eager to clean things up, so they will clean up your preview environments the moment you close the branch. The thing with Amplify is that they deploy resources into your account, and you will at some point actually run into the resource limits, like from AWS themselves. So they might create multiple. They will create multiple CloudFront distribute or deployments and separate like S3 buckets to deploy your code from. So that's probably what you will run into first, and then they will clean it up. But the cost kind of to have to keep these deployments around is mostly just, well, as if you're just storing files into an S3 bucket. If you would have like large videos in your deployment file, which you probably don't want, then that might become a problem. But if your website is only a couple of megabytes, then it's maybe not even worth it to ever clean it up, because lifetime cost of just having these files around will be a matter of cents even. And like I said earlier, Netlify and Vercel, they're responsible for cleaning it up. With AWS, it's a bit more on your for you, but at the end, it's also kind of there. They have tooling in place to automatically clean up. So usually doesn't become a problem. Like the real cost you will see with this platform is actually bandwidth and usage of your app. And hoping that you have a successful product, that's kind of where the cost will come from. Vercel does per commit, and they will time out at some point. So they did clean it up with a fixed number, depending on your pricing tier. Good. Thanks for the question, Robin. Let's continue. Oh yeah, good. Yeah, I was in the API area. So yeah, you see that on multiple reload, like after your serverless functions need to be invoked, which is a very typical performance characteristic of serverless functions, that you have these cold starts, which take 1 to 2 seconds. But if you have consistent load on your application, then you will see that there will always be something hot nearby to kind of serve the requests. Let's reload again, see if anything changed. No, we still see that kind of the deployment region for, in this case of Vercel deployment, is also in US East. So yeah, it would be nice to pick something close to your data source and or users, but it depends a bit on your application, what's smart there. Y Combinator website themselves. So let's see like the actual app kind of, so instead of using their API, it's a bit unfair because I know that this website doesn't use their own API actually. It's a server-side rendered app, which connects directly to their own database. It's hosted somewhere in US West, so you'll see quite high latency actually to kind of get the first page render. But the nice thing though is because it's all statically rendered, it doesn't need to do multiple run trips afterwards, which actually makes it quite, like the end user won't even notice it that much. So you know, speaks a bit in favor of having statically rendered websites at times. Yeah. Then it's harder to make it very dynamic. So not a complete deal breaker, but yeah, if you're in the US, you'll have a very good experience there. But if you're geographically farther away, it will be a lot worse. I'm about to wrap up the first half of the demo about deploying these static web apps. The second half is about deploying a container-based application. We'll be doing it to Fly.io. And the very bottom of the instructions, you'll find this link to the next one. So same stuff. There's a repository available. A separate repository for this. So we'll be, just to have a bit more, an application which actually needs this persistent always on, but it needs like its own database. It's a Redwood app, which is a Node.js framework. It splits itself into an API and a web layer. The web layer again builds a static website, and the API is like dynamic backend. But it tends to be that at least at the start it's easier to deploy them together. So then we'll serve the static assets from the same container. It will run with a built-in SQLite database. You can connect it to Postgres, but for sake of demo, I will stick with SQLite. The neat thing about Vercel is actually that they have, Fly.io is that they have the support for attaching persistent storage to these containers. Not all of the platforms I mentioned in my slides originally do have that support. So it's quite like, it's something we can use here, but otherwise you would probably want to push still your, let's say, your database to some other service, some kind of managed service, to not have to deal with that in your deployment, because deploying stateless services is a lot easier. But for this example, we'll just go with SQLite and not worry about that. So yeah, now I have a IDE connected to my Git repository. Let's start get going. So for a fly, I already said, I think I mentioned earlier, you do need a credit card when you create an account. You'll stay within their free tier. So if you want to join, you can set it up. They also won't charge you for your, they just do a verification check on your account, on your credit card. So we won't be deploying or developing locally anyway, so we don't need it. Cloud-based. Let's first install the fly.io CLI tool, and then we need to install the path. Yes. Normally you would install this, of course, into your bash or C file or somewhere that persists, but since this is a bit of a one-off anyway, we'll forego that. And log in. Section. Already logged in, so I can just get the CLI authenticated. Good. First, going to run fly launch, which helps you to set up basically bootstrap it for like a fly environment. In this case, again, these tools try to figure out what kind of framework you're using. That's called the app. Whatever. Okay, so the app. We don't need a database now. Fly comes with support for deploying databases, but it's not a truly managed database. Not sure how I feel about it. I've used it a couple of times, but they give you the deployments. They give you a template to deploy Postgres databases from onto their platform. It works, but you do need to be a bit of a, well, you need to be quite hands-on, and it's not as kind of managed as you would have with, for example, Azure managed Postgres or RDS or those kind of services are fully managed. While Fly gives you more freedom to manage it yourself, but it also gives you a bit of responsibility in that way. Yes, it might be that if you're tagging along, I already ran it, that's fine. It will try to update Yarn to some pre-release version, which will break horribly when we're later on in the process. Yeah, it's annoying. Yarn things doing Yarn things, I guess. So let's play this, see what this fly launch actually did. So we now have a new Docker ignore and a Docker file, and there's this new.fly folder and fly.toml. So if you first go into the fly.toml, this is their own configuration file. In this case, you check it in with the source code, and it tells how your fly app should be deployed. In this case, we have it together with the source code. You could do it separately. It would work slightly differently. And you probably also want to deploy directly from like containers you have pre-built. In this case, it's easier to just have, like, with these platforms, to have your deployment configuration living together with your application code, because then you can get this like flow where you deploy whenever you push a new version of your app, you kind of get a deployment, and then through branches you can manage the stable versions. In this YAML file, one of the important parts is configuring how networking works. Since it's a web app, we want it to be exposed to the internet, so we'll have some kind of load balancer in front of it. We get some health checks and like HTTPS, and a bit of rate limiting to make sure that we don't completely overload the app. We tell it to provision a disk. That's not as common in these platforms that actually support that. So it's sweet we get it here. Otherwise, you would have to go with some kind of external data source, and then we can configure the application. And one kind of thing we discussed into this platform, but most have them, is some kind of lifecycle hooks. So whenever an app starts or whenever you kind of roll out a new version, you can run some kind of command, which is very useful for if you want to control or have database migrations happen before you deploy your application, just that you don't you can tie those together and you don't responsible for kind of running it beforehand or after doing that. So also that's why for these lifecycle management, that's why they generate these files. You don't really need it. It's just a standard their scaffolding uses. At the end, they're just bash scripts. They run at the right time. So you'll see that release is what runs on release. That's, it just runs this migrate script, which in this case, Prisma is the database. Well, both that handles the database migrations and access an ORM. So it does that to run and see the database or to migrate their database schema. Last but not least, the Docker file. Here you do have usage of Docker file. So in this case, it's scaffolded something for us. It happens that this works, but you can tweak it to whatever you want. Just the normal Docker build kind of approach. There's also build packs. Which at least Fly supports. You see the same with, for example, Roku. So build packs encapsulate how to build an application into a container image as code. So it can do things like detecting the dependencies of your software or the programming language or the package manager and automatically satisfying the needs. So it's a way of writing reusable, think about reusable Docker files, which are programmatic rather than just this more imperative kind of way of writing Docker files, which at the end means that you're not replicating all this building logic between applications. For example, here you will see that now we pin to a certain version. It is a moving tag, but now we are taking responsibility of kind of bumping node whenever there is like security vulnerabilities. So with these build packs, they can kind of automatically select a suitable version and incorporate these best practices into your app. So makes your code a bit more dry. This file looks quite complex, and the reason is that Redwood has this bit of a monorepo kind of style where you build the API and the web layer separately, and then it all rolls it up into one container. But yeah, depends on your project, like how complex this would be and needs to be. So now that we know what we have to deploy, we can actually get to deploying it. So deploy. This will be a bit slower than what we will see on, so for example, with Vercel and with Netlify, but that's more to do with that this entire application is slower, or like it's more heavy to build it. And the again, it's a bit of a caching thing too. The kind of Vercel and Netlify reuse their builders, so they get like constantly cache hits on the exact versions, while in this case with Fly, the builder happens to be just to show that they provision a small machine VM for you to build the applications on. So what happens is that the Fly CLI, it pushes the files to this builder in the cloud, and there it builds the application, and then it pushes a container image into their registry that it can deploy to our application. The CLI does allow you to use a local engine. So if for whatever reason the version, for example, of the engine that you want or they provide for you is not satisfying your needs, then you can control it by building locally. Or let's say like you want it to be more powerful because you have a very expensive, like CPU intensive build step. Then you can use your local compute power instead of whatever they provide for your builds. Which I think by default comes with it's shared CPU, so not that powerful kind of machine. Yeah, cool. Let's see, where are we at? So yeah, creating release. So what they do is they push their image to their own registry, and then they start spinning up from that container. So yeah, like I mentioned earlier, they're using Firecracker VMs in the hood to deploy the container. We don't really need to actually worry about this. That's a nice thing. We just tell it to The only thing we kind of own now is this Docker file. But after that, it's not really our problem anymore how they do it. And here we got the monitoring. We can see the logs of the starting machine, VM, and in a minute we'll have it launched. So we also see mention things about health checks. So that's one of the things like we already saw it in the fly.toml. This is health checks, so it can know when the container is at least responding, so it doesn't immediately route traffic to it. Okay, health checks are passing, so we have a successful deployment. Find the link to our app, and ta-da, we have a running application. Yeah, try to sign up. In the monitoring, we'll see, we can figure out why this app is not happy. And the thing here is that we forgot to set the session secret environment variable, so it cannot guess what environment, like what application-specific environments variables which need to be configured. So now go back, and in the so yeah, this is session secret is used to encrypt the HTTP session. It just needs to be some kind of random nonce, which kind of makes sure that at least we have a reusable bit of randomness we can use between container starts, and then kind of check whether this secret makes sense. The flight secret sets secret is very secret. Oh, secret. Yeah. Secret are environment variables we cannot pull back through the UI or through the CLI, but they are in a way protected. Of course, the application will still be able to access it. So it's not that they are protected forever, but they are kind of within the UI. They are protected. And they're not as, you cannot read them back as normal environment variables, so they don't accidentally leak in through those means. In this case, we will see that it won't try to rebuild the application. We should just apply the changes to the environment variable. If you would like that to be available at build time, then you would need to trigger a new build. This should go pretty quickly. Yes, deployed successfully. Good. So let's try this again. Yeah, cool. Oh, we meant to log in. This also means that our database is working because we registered this new user, and we have a kind of broken application there. Now, next step is again, as in my previous demo, like how would you actually kind of develop against this? When playing this app, you will very quickly figure out that this doesn't work. Yeah, I took code out of the internet to do this demo, so it wouldn't be really a complete happy path where I just take my own code and deploy it and know exactly how it works. So we get all the nice bugs for free. Yeah, what happens under the hood is that they want some slug, which is Conduit is a kind of it's a blog platform. So then when you know to kind of find the slug, the part of the URL of your blog post, and for some reason they decided the application is done without it. So yeah, let's add that. So if you go to our source code, there the thing is missing. From source, this component for the form editing or the post editing where we create this post. Let's see where we are. So here we see that this is the title. So that's this element. Just going to insert a yet another field there, which actually allows us to set the slug. It's there. Oh. Our post editor. Post editor. Fly deploy. In more serious steps, it would get, like, for example, GitHub Actions to do the fly deploy automatically on our main branch instead of doing this locally. Would work fine for kind of small hobby projects if you don't have control over it, but already done, probably you want to have CD available to at least make sure that you keep deploying this latest version instead of manually doing it all the time. I just do it now to avoid watching or getting you to watch me write GitHub action code all the time. But it's quite straightforward to install to install the CLI tool, to install to start, authenticate it through some API token, and then get it to just run fly deploy, and then it deploys the latest version for you automatically. Yes. So that's a bit of bug fixing. So we will see that again. We'll have some caches probably on the oh, there you did it. All faster. Yes. So we get some hits here and there on things that already exist. And then soonish, see that here, the new container will be spun up, and then we soon have the new version of our application ready with the bug fix, and then we have a working blogging platform. It's just pending. Okay. Now it's going to wait until the health checks pass. And then as soon as it will kill them, yeah, it's stopping the old one now already. New one is ready. Okay, there we go. So there's this new field. So watch. There, done. Back. And there we have it. We have our first post. So with this, we're getting a bit to the end of the presentation or the demo. Are there still any questions? If not, I will wrap up. Okay, so in summary, what did we deploy? We deployed 2 apps to these 4 different services, 3 times the static web app. It's probably the most simplest to set up, especially if the framework you're using already supports it, which in greenfield projects would be kind of easy to select, but later on it might be tricky. Then you do get these deployments with static assets to CDNs, and then all your dynamic traffic would go to either your own backend outside of this deployment or your serverless functions. You see that these CDNs are pretty good at caching resources near the end user. So what it does allow you to do is to kind of have a first page, a skeleton, at least without dynamic data, and just render your website and have something meaningful for your user to see immediately. At least they're not looking at this white loading page all the time, but at least they will see some of the content, and then later on the dynamic content will be loaded in. From a collaboration point of view, you get all these like deployments on at least every branch, but probably also every commit, which allow you to easily share kind of working versions, or hopefully working versions you are working on. So it's easy to collaborate in this work in progress kind of mode. On the other side, if you do not fit this CDN or functional servers, serverless functions model, then we have this more like for a more dynamic web app approach, or even it can be background workers, something which can wrap up into a container. Then there are other platforms which it's a bit like Kubernetes, where it gives a platform as a service, but way higher level. You do not need to care about, I don't know, like things like where are your build artifact or your kind of deployment artifacts actually stored, and they come with things like configuration management, like secret management, often built-in load balancers. So there's a lot you kind of get for free for there. These longer lived processes can be slightly stateful themselves. So you could have like a local cache in memory if you would need to. Often they are more suited to having horizontally scaled applications which are stateless by themselves. So it should or it should be like a single VM with some persistent state, like I showed with the SQLite database. But that will prevent you from, it will make it hard to scale beyond that point. So probably fine for your hobby projects. Wouldn't do it in production for the bigger things. The nice thing is you have no kind of management yourself with these things. So all the infrastructure changes, the platform is making under the hood and keeping that infrastructure secure. That's completely outsourced. So they will just make sure that there's some version of your application deployed, and that is deployed to a new instance if they need to move it from one VM to the other. But you don't need to kind of maintain this layer of infrastructure yourself. Optionally, these are often they often do allow you to kind of replicate your application too. So for example, with Fly, you can configure which regions it deploys to, and you can tell it to deploy to or have multiple instances available. That still kind of you need to somehow figure out like where your data is going to live and how to replicate that. But they can at least help you with, at least getting compute close to your end users. With that, I'm going to wrap up. I think I've solved a bit of time, but if there are questions, then I can answer them now. Otherwise, thank you. You can connect with me on LinkedIn or on GitHub. I happen to use that nearly as a social media. Not sure if it's healthy, but it's at least a fun thing. And concludes the talk. So I promised earlier, right, that we have to like 2-second deploys. Let's insert some hello T-dot here on the bottom. Oh, more to the bottom, yes. Okay, going. Let's see here. Going. Pretty small. Let's see here. Pop up. Right there. So there we are. So I have hot reloading projects at work, which take longer than this kind of full deployment cycle, where going from making the change, committing it to GitHub, and actually getting it into production is faster than just restarting your local web server. The reason why this works is that it's a Go-based static site generator, and it's just blazingly fast. Running this locally would take a couple of milliseconds for a complete rebuild of the site. So what happens is that when I push a new version, Vercel picks up, they already have a runner available with at least a cached version of this Hugo builder. They just run this couple of millisecond build on their side. Then they distribute the files and invalidate all the caches, and nearly instantaneously you will see that on my log, like all the end users will see this file propagating. It's I find it kind of neat that that's possible. So again, only a couple of seconds to build.
Hi, we're from Efficode, and we're delighted to organize the DevOps conference.
The interactive track at our conference has a unique opportunity for speakers and audience members to engage in dynamic conversations. It fostered a collaborative learning environment. Our tailored coaching services can also help you to overcome challenges in your software development life cycle. Let's have a chat.
Connect with us at efficode.com and let's push the boundaries of software development.